11th and 12th grade, they wouldn't know Miss Johnson, who teaches science. And Miss Johnson is pretty fantastic.
Hey, my daughter keeps saying, I understood chemistry because of the Johnsons.
Yeah, there's 2 Miss Johnsons that teach science.
So she calls them the Johnsons.
Okay, but today we're not going to talk about how that data was collected. We're not going to talk about if it was biased, the way it was collected, or who we asked. But we're going to be thinking about, we're going to assume that the data collected was scientific. The way it was collected was right. Abdurrazak, dude.
I'm just
Okay.
I'm here to babysit.
Yeah. Okay, but we're going to look at how they're displayed. Okay, and the way that it's displayed is different. All right, so it's may lead to incorrect assumptions. All right, so it may lead to incorrect assumptions. And by saying it may lead to incorrect assumptions, we're saying that the people who made these graphs, they're trying to get you to assume what they want you to assume. They're trying to manipulate you.
These graphs were not a mistake by the people who made them. Guys, seriously. Gross. I would not want to use your phone now.
Okay. So as we take a look, what's our first graph about? Yeah, already, without looking at the graph, what are you assuming? There's going to be a really big decrease, massive decrease. So already in this title, the massive decrease, we wouldn't want that in the title. The way that that's labeled is already leading us into something about thinking about that graph. We should just call that house prices and let the reader determine what they thought of it. Okay? So, really important. Titles are important the way that we talk about them. Now, with massive decrease in house prices, Bruce, bruh, just write the notes. Come on, man. All right, so as we look at this from one year to the next year, it goes 2006, 2007. What does it look like is happening from one year to the next year? Huge decrease, yeah. It's like half the price for like the same house. That's a crazy sale, right? Really, really good. But when we look at it more in depth, this first year, 2006, how much was it in 2006? What's this at?
Can you see the price?
Okay, 311,000. What? Oh. Did all of you, the rest of everyone get a paper up there? Oh. Okay. Sorry. All right, and then in 2007, we think it's about half. So half of like 300,000 is 150,000. Is 2007 at 150,000? No, what's 2007 at? 309,000. So did it get cut in half? No.
Not even close.
So how much did it actually change from 311 to 309? 2,000, yeah. So $2,000 difference or $2,000 change. Which, depending on what we're talking about with money, $2,000 can sound like a lot of money. Okay? However, when you're buying a house, the difference between $311,000 and $309,000, is that a big difference in house prices? No. It would be kind of a nice little bonus of like, oh, I saved $2,000. Okay? But it's not something that's going to decide if you're going to buy the house or not buy the house. $2,000 isn't that big of a difference. Okay.
Can I give an example?
Mm-hmm.
Last night I was working, and there was an auction, so people were raising money. And somebody spent $2,000 to buy a Vikings helmet. A helmet from the Minnesota Vikings. It was Justin Jefferson, and it was signed. Okay, so that's a big deal. So he spent $2,000 to buy that. The money goes to charity, but he spent $2,000. That seems like a whole bunch of money for a Vikings helmet. But if I'm going to buy a house that I plan on living in for a really long time, then $2,000, oh, okay, I can do it. But if I'm going to go home with somebody's Vikings helmet for $2,000, I'm like,
That's a crazy amount of money.
yeah, for me that was a lot of money.
I would not have done that.
I couldn't have done that, no.
All right, so when we look at this, what's really important, we're going to kind of make some notes because on your test on Tuesday, it's going to give you some examples of graphs, and you get to pick one graph and you have to say what's wrong with it. Okay, so we're going to kind of just make some notes, some things to look out for.
So if you take notes and you listen, you have the answer to one of your test questions.
Yay. Okay, so scales are really important on the x and the y axis. That's always something to look for. Okay, is that always look for the scales on the x and the y axis. Okay, on the y-axis this time, this is the one where they didn't do that scale. The people that made this graph are assuming what point do we usually put at this corner? 0. The people who are having you read this graph are hoping you assume that this is 0. Because if this was 0, then yeah, that would be half. Okay? But it doesn't start at 0. They're hoping that you just glaze over it and don't see that. And see that it looks like it's half. So that's really important that it should start at 0 to show change. Okay, and then the other one that we talked about that was in the video that isn't necessarily in this one, because this one, once it starts counting, it does count evenly. It goes by thousands. But we have to make sure we have equal intervals. Which, remember, intervals are what we count by. And that's kind of that one that was showing those months. The months and the years, it wasn't counting by the same amount of months every time. One jump was 15 months and one jump was 6 months. Okay, when we count, we have to make sure that we're counting equally as we go. All right, we have 2 graphs now that we're going to compare. The next 2 graphs are showing the economy, the GDP per capita, the gross domestic product. I know geography and math and science and social studies.
Economics.
Yep, that. I did take economics actually in college. It's embarrassing. All right, so as we take a look at this, which economy looks better? The economy on the left or the economy on the right? Why is the one on the left a better economy? Why would you want to live in this country? Yeah, it's overall what's happening. Going up. Does it go down sometimes? Yeah, by a lot or a little? Yeah, just by a little. It goes down or sometimes flattens out, but overall the trend is going up. It's positive. What about this country on the right? What's happening here? Yeah, huge decrease. Goes up a little bit at the end, but dang, that looks like it was a hard year. You want to know a secret? These are the same country. Okay, this is both the United States. If you look at the titles, they both say real GDP per capita in the United States. They're the same thing. Okay. Down here, what years are they using for the one on the right? Yeah, 2007 to 2011, where the one on the left starts at what year about? Yeah, 1970 is here, so really like 1960s. So 1960s to 2000s.
Okay, wait. Can I just make a statement? This graph here starts when I was born.
Whoa.
Yeah. So this graph here is showing you like a whole bunch of years. This graph started when I was born, and it kept, this is all the data from when I was born to 2010.
Yeah, 2010 or 2011, somewhere in there.
I can't see that.
Okay.
Okay.
So what part of the graph are they zooming in on for this part?
Can you tell?
Can you kind of match it where it goes?
We'll see.
It goes right at the end here. This is this part. They took that little part of the graph and they zoomed in on it to make it look like it was a really big change. And it was a big change, but overall, in the realm and the idea of the trend, is it a big change? No. And overall, we know the trend is still going to go up. Okay? When you zoom in on this, this is what they do a lot in politics. They'll say, okay, under this presidential candidate or underneath this president, look at what happened to our economy. It went so far down. That president was so terrible. Okay? And both sides do it, both the Republicans and the Democrats. It's not just one side or the other. Or they might like cover up half of this and be like, okay, now look at what happened. The president came in and it went down, but then the president helped recover that economy. It went up. Okay, and that's how they use that to manipulate you. They're trying to look at just one part to really exaggerate what's happening in that short time frame. Okay, this is what that video was calling cherry picking. So this is an example of cherry picking, which is kind of a weird word.
It is, but out of this whole graph, at this point would have been like 47 years, they picked like this little tiny blip right here and blew it up.
Okay, and that's the one that they were doing with the vets. We noticed with the vets it said 5 out of 5 animals, but how many animals actually started the test? 20. Okay, they didn't show all 20 animals. They only picked the 5 that they wanted to show. Okay, and that happens, they mentioned it happens with antidepressants. That happens a lot with pharmacies. Pharmacies will run these like tests and these data to show you that their medicine works. But then if you look at the government research, or you look at a third-party research, the third party means somebody who's not invested in getting in the profits. The third-party research will show that that's not really what happened when you look at the overall data. So cherry picking is a really good way to really manipulate you or tell you, like, you need to buy this product because this is what's happening. I'm only going to show you what I want to show you. I'm not going to show you everything, just part of it. Okay? So,
and then people who create these graphs hope you don't realize it. So they're banking on you being
not very smart.
not very smart.
Or they're hoping that you just look at it quick and don't think about it.
Yeah.
Okay, so cherry picking means that we're only using a range or set of data points so we're only using this one, it's a range. They zoomed in on one specific part. The one with the vet, where they only picked 5 out of the 20, that's just selecting a set of the data points, okay, to support your argument. So whatever you're trying to convince people of doing, it's going to support that argument. Okay, so this is an example of cherry picking where they had a bigger graph. They zoomed in only on a little bit of it to make it look different. And not that we can't look at that part of the graph and say, okay, yes, our economy in those years did decrease, but it is important to still look at that overall picture. Okay, now Ms. Jensen said earlier that these were done on purpose. I don't know if this next one was done on purpose. I think this next one, the person making it was like, let's make a graph fun. Okay?
Oh,
This one.
I thought it was done on purpose.
Well, you said all these were done on purpose. This one, I don't know if it was done on purpose.
Okay.
I don't know. Maybe it was.
No, I just meant like they're very intentional. I shouldn't say on purpose, but they're very intentional. People are very intentional.
Yeah, this one I think the person who made it just didn't quite get it.
They weren't thinking.
They just weren't thinking. Okay. Okay, this one's talking about average female height. What's wrong with this graph? Yeah, people from India, they're little ants. They're teeny tiny. Okay, India people, they're saying like, oh, they only go up to the knees of people from Latvia. Do you think that people from India are that teeny tiny? No. How tall is the person from India? 5 feet. But they're 5 feet and they're only going to the person's knees. That person who's from Latvia, if that's 5 feet, how tall is this person from Latvia? Like 20 feet tall. Is this person from Latvia a giant? A bit giant? Question mark? Okay, according to this person from India who's 5 feet, if I stack that person from India on top of itself, it would be at least 20 feet tall. Is the person from Latvia 20 feet tall? No. How tall is the person from Latvia? 5'5". What's our difference between our shortest and our tallest? 5 inches. Is somebody who's 5 inches shorter than you going to be at your knee level? No. Okay. So this one, there's a couple things. The scale on the y-axis was a little goofy. Yes, that's true. Okay. But also using these pictures can be a little misleading. So when we do this, we don't want to use icons or pictures. I was looking at a different one earlier that was doing logos of restaurants, and the McDonald's logo, because it's an M, it's so wide, it made it look like it was way bigger than Arby's, because Arby's is a little bit more narrow. But really they were like the same, but because we used the M for McDonald's, it made it look way bigger. Okay, we want to make sure that these parts look like they're representing the same person or the same thing. So when we do this, we want to make sure that we use bar graphs. And when we do bar graphs, we want to use actual bars. We can use histograms or dot plots. I'm going to zoom in there so you can read that. Sorry, wrote kind of small. Okay, when we use those icons or pictures, it can really make things look crazy. Okay? Should show you the Elsa one from Frozen. In Frozen, Olaf is supposed to be like 5'4", and then he goes and stands next to Elsa. And Elsa's like 20 feet tall, because they made it look like so crazy different. All right, this next one. I feel a little embarrassed about this next one. It took me a really long time to figure out why this next one's misleading. Like, much longer than it should have. So if you look at this next one, it says gun deaths in Florida. So the number of murders committed using firearms. Firearms are just guns, weapons. Okay. If you look at the graph here, this was published in a news article about this Stand Your Ground law and how it was making a positive impact. Okay, this person was definitely hoping whoever was reading this newspaper would look at it and then just flip to the next page and say, oh my gosh, I saw a graph. Look, it was great. That gun law obviously is doing great things. Okay, so take a look. Why would it look like in this one that the gun law is helping? Yeah, it goes up, 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 goes a little down, goes back up. We hit that gun law, then what happens? It goes down, and it stays down. So that gun law must have been really helpful, right? Okay, but if we actually look at the numbers, take a look. How many murders were there at this point? Yeah, it's above 600, but what's actually above 600 this time? We're getting closer to 400. So this is actually like 520. And at this point here, where it looked like it decreased, what is that actually at? Yeah, like 810. So they made the graph look like the murders decreased, but when we look at the numbers itself, what actually happened with the numbers? It increased. Okay. I spent a really long time looking at this graph. I thought it was because they shaded the top black and the bottom was white, and they shaded the bottom black and the top white. It took me a really long time to be like, why is this bad? Okay, eventually I realized by looking at these beginning and ending numbers, I realized like, oh, 721 is smaller than 871. Why is it above? Okay. Go so fast, Bruce. Okay, it was a little confusing to me. And then I was like, that's not right. And then I finally looked at this y-axis. What did they do on this y-axis? Yeah, they flipped it upside down. Okay, I fell for this one. I don't know. I just thought this one was crazy in my brain. Like, what the heck? I just would never even think to make a graph like that. So whoever thought of that was really smart about how to get their point across fast. Okay, when I look at this, my brain interprets it really fast. It says, oh, it's going down. That means it's good. But when you actually look at it, it's increasing. So what's really interesting and what I really appreciate is even since when I was in high school, I know I was in high school like 20 years ago, but we talked a little bit about biases like in the newspapers and in articles, like how the writer, whoever's writing things, the way that they present ideas might be trying to sway you. But we never talked about how math might be trying to sway you. Okay? The way that they present their data and their research can sound like it was really good and well done, and it might have been really good and it might have been really well done, but what they present to you might be trying to get you to sway into what they're trying to say. It might not quite be the whole picture. Okay. Ms. Jensen, do you have any other wrap-up summary ideas?
I don't. Any questions? I hope this makes you look at graphs a little bit more closely, because